In this lesson, we're going to focus on conducting a hypothesis test called the goodness of fit test. This is going to be the first hypothesis test that involves qualitative, also known as categorical variables. Let's start by reading the learning objectives. After this lesson, you should be able to state the null hypothesis and the alternative hypothesis for a goodness of fit test. You should also be able to organize the observed and expected count for each category on a contingency table. When conducting this type of test, it's really important to stay organized. Now, the third learning objective is to calculate the chi-square test statistic for a goodness of fit test. And that is where we're going to spend most of the time in this lesson. We're going to spend most of our time finding that test statistic. So I'm already telling you here, this is going to be a challenging step, calculating the test statistic. Now, your last learning objective is to be able to conduct the hypothesis test for a goodness of fit test using the p-value approach. Once we find the test statistic, we're going to use this value to find the p-value. We're going to find the p-value using technology. So again, that is why I'm saying that most of our time is going to be spent calculating the test statistic. So when are we going to use the goodness of fit test? This hypothesis test is going to be used to determine whether data follows or fits a particular distribution or not. So again, you're going to have a distribution. You're going to be wondering, does this distribution follow this other known distribution? Okay. So you can say follows, you can say fits. We're going to be conducting a hypothesis test using the same steps we had for a hypothesis test for a mean and for a proportion. Okay? Step one is going to be to state the null hypothesis and the alternative hypothesis. Step two is going to be to find the test statistic. Okay? And this is going to be the step that takes us the longest. Using the test statistic, we're going to find the p-value. Once we have the p-value, we're going to compare the p-value with the alpha value, and we're going to make a decision. Are we failing to reject the null hypothesis, or are we rejecting the null hypothesis? Once you make a decision, you will be ready to state the conclusion of the hypothesis test. Okay. Now, for the goodness of fit test, the null hypothesis is always going to state that the data follows or fits with a specific distribution. Okay. So you can think of this as, okay, so here we would say, we don't have any evidence, or we don't have sufficient evidence to say that the data that we're looking at doesn't fit or follow the known distribution. Okay. Now, the alternative is going to challenge that statement. The alternative is going to state that the data does not follow or does not fit with a specific distribution. Okay? And so once we have a specific problem that we're looking at, we're going to make sure to use the context of the situation. Now, to be able to use the distribution for this hypothesis test, we need to have a sample that was randomly selected. And we also need each expected value in each cell to be at least 5. Okay? So it can be 5 or more. Here you can think of this as we need each expected value. Okay? We need the expected value for each category to be at least 5. Okay? Remember, we're working with a qualitative variable, with a categorical variable, so we're going to have categories. The expected value for each of those categories has to be at least 5. So if those conditions are met, we can go ahead and use the chi-square distribution and we can run the hypothesis test. How are we going to find the test statistic? The test statistic is going to be found using the formula here below. Here in the formula, we see that we're going to be taking the sum of this expression here, O minus E squared divided by. We're going to take the observed value minus the expected value. We're going to square that and we're going to divide it by the expected value. We're going to find this expression, or this value, we're going to find this value for each category. category, we're going to have an observed value and an expected value. For each category, we're going to take the observed value minus the expected value square divided by the expected value. Okay. Once we do that for each category, we're going to take the sum of all those values. Here below, we have some space to make some notes. Let's remind ourselves that O represents the observed values. And these are going to be values that come from the sample. And again, you have an observed value for each of the categories. Now, E is going to be the expected values. And we're going to need to calculate the expected value for each category, and we're going to use theory. You're going to need to use rules of probability to calculate the expected values. Okay? Now, what is going to be the degrees of freedom? Okay? The degrees of freedom is going to be equal to the number of categories minus 1. So I'm just going to go ahead and write it here. We don't have a symbol for the number of categories, so I'm just going to write number of categories in parentheses. So again, DF is equal to the number of categories minus 1. Remember, we're working with qualitative variables. For a qualitative variable, we have categories. You're going to look at how many categories you have, and you're going to subtract 1. That is going to be the degrees of freedom. Okay? Once you have the test statistic, you're ready to find the p-value. Okay? Now, let me go ahead and help you visualize how we're going to be finding the p-value. Here on the right-hand side of our screen, we have a chi-square distribution. Here, I'm going to label the test statistic. Your test statistic is always going to be on the right-hand side of the distribution, on the right tail. Your test statistic is always going to be positive. Okay? So let me go ahead and just write test statistic. Okay? The test statistic is a representation of the difference you're seeing between the observed values and the expected values for all the categories. Okay? So again, it's always going to be a positive value, and you're wondering, what is the probability of observing such difference, such test statistic, or something bigger than that? For this reason, the p-value is always going to be the area on the right tail, okay? The area above the test statistic. So if you're using a calculator, you need to press on second bars to get the list of the distributions, and you need to look for that chi-square CDF distribution. That distribution is going to ask you for your lower bound, your upper bound, and the degrees of freedom. Your lower bound for this test is always going to be the test statistic. Your upper bound is always going to be a really large positive value. We denote that using 1E99. And then you're going to enter the degrees of freedom. Again, the degrees of freedom is the number of categories minus 1. Now, if you're using Google Sheets or Excel, you're going to type equal CHISQ, which stands for chi-square, dot DIST, which stands for distribution, dot RT. RT stands for the right tail. This distribution is going to give you the area to the right of the test statistic you enter inside the parentheses. Okay? So inside the parentheses, you're going to enter the test statistic, comma, the degrees of freedom. And again, once you find your p-value, you're ready to make a decision. You're going to compare your p-value with alpha. That is going to help you decide if you're going to reject the null hypothesis or fail to reject the null hypothesis. And then you can write a conclusion based on your decision. Okay. We're going to transition into looking at an example where we need to conduct a goodness of fit test. Okay. And I will make sure to emphasize how we know that we need to conduct this type of test. Okay, so let's go ahead and read the problem. Employers particularly want to know which weekday employees are most likely to be absent due to sickness. Most employers would like to believe that employee absences are spread equally throughout the week. So let's go ahead and stop there. Look, we're going to be looking at the number of absences during the week. And here it says most employers would like to believe that the number of absences are equally spread out. So think about it. This is the expectation. So here, with this expectation, we're saying the probability of someone calling in sick on Monday is the same as the probability of someone calling in sick on Tuesday, which is the same as the probability of someone calling in on Wednesday and Thursday and Friday. So we're expecting to see the same count for each day: Monday, Tuesday, Wednesday, Thursday, Friday. Okay? So here is an expectation that we have. This sentence here is going to help us find the expected value for each of the categories. Okay? And here the categories are Monday, Tuesday, Wednesday, Thursday, and Friday. We have 5 different categories. Now, suppose a random sample of 60 managers were asked, how many days of the week did you have the highest number of employee absences? Okay, so this is our sample size. N is equal to 60. Okay. And so here on this table, we have the results coming from that sample. So what we have here on this table is the observed values. Okay. Again, remember, the observed values are going to be the count that you see on each category coming from the sample. Okay. So here we see 15 for Monday, 12 for Tuesday, 9 for Wednesday, 9 for Thursday, and 15 for Friday. Those are the observed values for each of the categories. Now, we're being asked to conduct a hypothesis test to determine if the population of employees is absent equally during the week. What we're saying here is that, does the data coming from the population of employees, does this follow this distribution here, which is a distribution where we see equal absences during all 5 days of the week? You're not directly being asked to conduct a goodness of fit test, but you should know that you need to conduct a goodness of fit test because you're trying to determine if the data coming from the population of employees follow this distribution here. Okay. Now, here we're being asked to use a significance level of 0.05. Okay. We're going to keep that in mind, and we're going to need that later to make a decision. Okay. So let's start with the first step. We need to state the null hypothesis and the alternative hypothesis. Now, there's different ways of stating the null hypothesis and the alternative hypothesis. First, I'm going to show you how to state the hypothesis using words. For the null hypothesis, we're going to say, let's assume that the data does fit this distribution. Let's say that we do expect the employees' absences to be equally distributed during the week. We're going to write the employee absences are equally distributed during the week. In other words, we're saying the employee absences do follow this distribution that you're expecting to see. They are spread out equally throughout the week. Now, the alternative hypothesis would be that the employee absences are not equally distributed during the week. So let me just copy the sentence that we have here above, and I'm just going to add the word not, meaning they are not equally distributed during the week. Now, you don't have to always write the hypothesis using words. You can also use mathematical symbols. So let me give you an alternative. I'm going to go ahead and write this using statistical notation. For the null hypothesis, we can write the proportion of people who are absent on Monday. We can write P sub M is equal to the proportion of people who are absent on Tuesday. Let's write P sub T, which is equal to the proportion of people who are absent on Wednesday and Thursday. So I'm going to go ahead and continue using this notation. I'm using P sub M for the proportion of people who are absent on Monday, P sub TH for the proportion of people who are absent on Thursday. All of these proportions are also equal to P sub F, which is the proportion of people who are absent on Friday. Now, for the alternative hypothesis, we can say that at least one of these proportions is different than the others. Not all of them have to be different. We just need one to be different than the others. So we can go ahead and just write at least one of the proportions is different from the others. So this is an alternative. This is another way of how you can state the null hypothesis and the alternative hypothesis. Now here, On the null hypothesis, I can also indicate what those proportions are supposed to be equal to. You can think of those proportions as a value that can help you find the percent of people you're expecting to see on Monday, on Tuesday, Wednesday, Thursday, and Friday. These proportions are equal to 1/5. The probability of someone being absent on Monday is 1 out of 5. The probability of someone being absent on Tuesday is 1 out of 5. So here on the null hypothesis, we can state this value. If you don't state that value, it's okay. We're still going to need that value later on when we calculate the expected value. Now we're going to transition into finding the test statistic. We're going to use tables to stay organized. Let me go all the way down to remind you about the formula that we use to find the test statistic. We're going to need the observed value for each category. So the observed value for Monday, Tuesday, Wednesday, Thursday, and Friday. We have those values. Those are the values coming from the sample. So we have nothing to worry when it comes to the observed values. They're given to us. However, we need to find the expected value for each category. We need to find E. That is going to be our first step when finding the test statistic. Finding the expected value for each category. Again, here the categories are Monday, Tuesday, Wednesday, Thursday, and Friday. And let me remind you that for this problem, our sample size is equal to 60. So if your sample size is 60, how many of those 60 are you expecting to see on Monday? There's different ways of doing this. Some of you might be thinking, well, I can take 60 divided by 5, and that will give me the expected value for each day, because if absences happen equally throughout the week, then we would expect to see 12 on Monday, 12 on Tuesday, and so on. 12 for each day, for a total of 60 people who are in our sample. So that's one way to think about it. I'm just going to go ahead and do it the most formal way, which is using probabilities. If the probability of someone being absent on Monday is 1/5, then I can go ahead and multiply that probability by our sample size, which is 60, and that is how I get 12. Same thing with Tuesday. If the probability of someone being absent on Tuesday is 1/5 and our sample size is 60, then the expected value for Tuesday is 1/5 times 60, which is equal to 12. So that is going to be the case for each of the categories. I like to show you how to do it the formal way, because if the probability for each of those categories was different, then we would just need to take that probability times the sample size. Okay? So for example, if the probability of someone being absent on Monday is, let's say, 20%, then for the expected value, we're going to have the probability, 0.20, times the sample size, which is 60, and that is going to give us the expected count. So I like to think of finding the expected count by taking the probability for that category times the sample size. Okay, so now we have the expected values. Okay? So with those values, we're ready to move on to finding the test statistic. Remember, when finding the test statistic, we need to take the observed value minus the expected value. We're going to square that expression, and then we're going to be dividing by the expected value. Okay? The observed values are the values that we got from the sample, the values that were given to us on the table here above. So we have those values. Let's go ahead and write the expected values that we found. The expected value for each category is 12. So let me show you how to calculate O minus E squared divided by E. Let's start with Monday. For Monday, we have 15 for the observed value and 12 for the expected value. So we're going to take 15 minus 12, which is equal to 3. Now next, we need to take O minus E, and we need to square that value. O minus E is 3. So here we're going to be taking 3 to the power of 2, which is equal to 9. So for this category, O minus E squared is 9. Next, we take O minus E squared divided by E. O minus E squared is 9. So here we have 9 divided by the expected value. The expected value is 12. Now, if we take 9 divided by 12, we get a terminating decimal. We get 0.75. So we can go ahead and write 0.75. But if this was not a terminating decimal, you would just leave it as a fraction. Don't even worry about reducing the fraction. Just leave it as a fraction. We can just add the fractions at the end. So again, O minus E squared divided by E for Monday is 0.75. Okay? Now let's go ahead and do Tuesday. For Tuesday, we have 12 minus 12. The observed value is 12. The expected value is 12. Here we're going to get 0 for O minus E. Next, we square that value. We take O minus E squared, that is 0 squared. We get 0. And then we take O minus E squared divided by E. Again, O minus E squared is 0. So here we just have 0 divided by E. E is 12. So 0 divided by 12, which is just going to be 0. I went through all the steps. I knew that our answer was going to be 0 as soon as I saw that we had 12 minus 12, which is equal to 0. Okay, but I just wanted to go through all the steps. Now for Wednesday, we have 9 minus 12, which is negative 3. Then we're going to square that value. So we have negative 3 squared. If you're doing this on a calculator, make sure to place parentheses around the negative 3. If you don't use parentheses, you're going to get negative 9 instead of 9. Again, here, negative 3 squared is the same as negative 3 times negative, which is positive 9. Now that we have O minus E squared, which is 9, we're going to take that value and we're going to divide it by E, which is 12. So here we have 9 divided by 12, which is 0.75. Now, for Thursday, it's going to be exactly the same as what we did on Wednesday, because notice the observed value is the same as the observed value that we have on Wednesday. The expected values are also the same. So I'm just going to copy and paste the work from the column above. Now, on Thursday, we have an observed value equal to 15 and an expected value equal to 12. Notice these are the same values that we had for Monday. So I'm just going to go ahead and copy those values. O minus E squared divided by E for Friday is going to be 0.75. Again, if we had a fraction and we were to enter that fraction into the calculator and we get a value that is not a terminating decimal, then we would leave that expression as a fraction. We don't want to do any rounding here. Now that we're done computing O minus E squared divided by E for each of the categories, to find the test statistic, we simply need to add all those values. So here we're adding all the values on the last column. And so here, let me show the work. And I'm going to show this using the fractions. So we had 9 divided by 12 plus 0 divided by 12 plus 9 divided by 12 plus 9 divided by 12 plus 9 divided by 12. Again, here I'm trying to emphasize that we're simply taking the sum of O minus E squared divided by E. I know that the fractions simplify very nicely, but it's not always the case. That is why I'm using the fractions here. Again, I'm doing this step by step to emphasize how you would do this for any problem. When you add those fractions, you should be getting 3. This is the test statistic. With this test statistic, we are going to be able to find the p-value. Okay? And so let me go ahead and copy the functions that we're going to be using on the calculator, Google Sheets and Excel. I'm going to go ahead and copy those functions for this step. If we're going to be using a calculator, we need to use the chi-square CDF distribution. Then we're going to enter the test statistic. The test statistic is 3. Then go ahead and type in a comma. Your upper bound is always going to be 1E99. Your degrees of freedom, let's make a note of this. What is the degrees of freedom here? The degrees of freedom is the number of categories minus 1. How many categories do you have here? Well, you have Monday, Tuesday, Wednesday, Thursday, Friday. That's a total of 5. So the degrees of freedom is 5 minus 1, which is equal to 4. Okay? It's really important to find the degrees of freedom because you're going to need the degrees of freedom to find the p-value. Okay? So going back to the calculator function, we're using chi-square CDF. The lower bound is 3. The upper bound is 1E99. And the degrees of freedom is 4. Now, if you're using Google Sheets or Excel, you're going to use equal CHISQ .dist .rt. You're going to open a parenthesis. You're going to enter the test statistic. The test statistic here is 3 and the degrees of freedom, which is 4. Again, notice you cannot find the p-value without having the test statistic and without having the degrees of freedom. Let me show you how to do this on a calculator and how to do it on Google Sheets. On the TI-84 calculator, you need to press second and then press bars. You're going to get the list of the distributions. You're going to go down until you see the chi-square CDF distribution. For me, that is option number 8. Press enter. And now you're being asked to enter the lower bound, the upper bound, and the degrees of freedom. Again, the lower bound is going to be the test statistic. The upper bound is always going to be 1E99. The degrees of freedom, in this case, is 4. the number of categories minus 1. Go all the way down and press enter. Press enter again, and there you have it. This is the p-value. Make sure to try it on your calculator, see if you're getting the same value. We're going to need this value. Go ahead and write it on your note. Now let's do this on Google Sheets. Click on an empty cell, type in equal CHISQ.dist, and see, here I see the options. I want the option that has RT at the end because I want the area to the right of the test statistic. So I'm going to click on that option. Again, this is going to ask me to enter the test statistic, which is 3. It's also going to ask me to enter the degrees of freedom, which is 4. Close the parentheses, press enter. And there you have it. This is your p-value. So again, try it on your own, see if you're getting the same value. Go ahead and write this value on your notes. We're going to need it. This is going to help us make a decision. So let's make a note of the p-value. The p-value in this case is 0.5578. And here, you know what? I'm just going to go ahead and round to 4 decimal places. Now, I wouldn't want to round to 1 decimal place or 2 decimal places because I'm going to be comparing this value with alpha. And here, alpha is 0.05. So again, I would want to round to 3 or 4 decimal places. With this p-value, we can make a decision. Are we going to reject or fail to reject the null hypothesis? Okay? Now remember, this is a right-tailed test. Perhaps we should go ahead and visualize what we found. Our test statistic here is 3. The p-value represents the area above that test statistic. And remember, the test statistic here represents how far the observed data deviates from what we were expecting to see according to the null hypothesis. Okay? So again, the expectation was made assuming that the null hypothesis was true. Okay? So we're saying if this test statistic is giving us a good idea of how the observed data values deviate from the expected values, then we're asking ourselves, what is the probability of that value being 3 or bigger than that? The probability of observing a test statistic equal to 3 or bigger is 55.78%. So we were expecting to see such test statistic. Let's go ahead and make a decision. To make a decision, we need to compare the p-value and the alpha value. The p-value is approximately 0.5578. This value is greater than alpha equal to 0.05. Because the p-value is greater than alpha, we're going to fail to reject the null hypothesis. And now we're ready to write a conclusion. There is no sufficient evidence to conclude the alternative hypothesis. And what was the alternative hypothesis? Well, let's just copy and paste the alternative hypothesis to conclude that the employee absences are not equally distributed during the week. So that is the advantage of writing the alternative hypothesis and the null hypothesis using words. You can just copy and paste the sentence that you have for the alternative hypothesis when you're writing your conclusion. Again, notice here, we're saying there's no sufficient evidence to go with the alternative hypothesis. In other words, there's no sufficient evidence to conclude that the employee absences are not equally distributed during the weeks.